Hi guys, welcome to my channel. For today's video, we're going to discuss two types of functions. So the first one is the one that you're seeing right now, which is the logarithmic functions, and then the other one is inverse. And then let's start with logarithmic functions. For the reference of my students, you can read more about it from page 154 to 171 of your books and 202 to 204 of your books for the problem-solving part of logarithmic functions. Now, so what do we mean when we say logarithmic? So when we say logarithmic, the exponent, it means that we have the exponent that indicates the power to which a base number is raised to produce a given number. So example, if we have the logarithmic equation that you're seeing right now, we have logarithm of 4 base 2. So logarithm of 4 base 2. So we have our base, which is 2, which is equal to x. Again, this is being read now as logarithmic of 4 base 2 is x. So it means that we are representing an exponent here, which is being indicated as the power of a base. So next. Logarithmic function is indeed only the inverse of exponential function, just like what you are seeing. For logarithmic function, we have logarithmic of x base 2 equals y. So if you are going to translate this to exponential function, which is our topic last week, it's now a raised to the power of y equals x. So as you can see, our range is x and the element of our domain is being represented by y. So that's why we call it inverse. So when we say inverse, it's actually the way of interchanging the elements of x and y in a given function. So if you are going to translate, so this is being read as logarithmic of x base a equals y, or logarithmic of x base a is y. So our a is our base and our power is y equals x in the other side of the equation. That's how you will translate logarithmic function to exponential function. Next, let's have the first example. Convert, then solve for x. In our logarithmic equation, logarithmic of 16 base 4 is x. So how are we going to solve for the value of x? Just remember that before we can solve for the value of x here, you will have to translate this first or convert this first to exponential function. So our base, again, logarithm of 16 base 4, our base is 4, which is raised to the other side of the equation, which is x, equals 16, the logarithm of 16. So this is now our exponential form. Alright? Now, again, logarithm of 16 base 4 is x, wherein our main base is 4, raised to the power of x equals 16. Now, how are we going to solve for the value of x? Don't worry guys, this is very easy. We can easily solve for it by just making the bases similar. So our main base here, our bases here are 4 and 16. And the base that we can use to serve as a factor is 4. So let's try using the base of 4 to solve for x, or to make the bases similar. So just like the lesson last week. So just bring down 4 raised to the power of x. And the question is, how many times will you multiply 4 to get 16? Let's try 4 times 4. What's the answer? Okay, very good. It's 16. So it means that we have 1, 2. We will multiply 4 twice to itself. So as you can see now, just like the lesson last week about exponential, if the bases are similar, we can just simply equate the exponents. We have now x equals 2. And the value of x is just simply 2. Teacher, what if I'm going to use the base of 2, which is a prime number? Okay, so let's try base of 2. So for the base of 2, okay, so first is how many times will you multiply 2 to itself to get 4? Okay, so we have 2 times 2 equals 4. We have 1, 2. So therefore, you will multiply 2 to itself twice times the exponent, which is x, equals 2. And then how many 2's will you multiply to get 16? Okay, so we have 2 times 2, 4. Then 4 times 2 is 8. And then 8 times 2 is 16. How many? 1, 2, 3, 1, 2, 3, 4. So you will multiply 2 to itself 4 times. Now, we can equate because we already have our similar bases. So we have 2 times x, which is only 2x equals 4. And then to isolate x, you have to divide both sides by 2. So cancel 2, x now will be equal to 4 divided by 2, which is 2. Okay? So whatever base that you will use, you have to make sure that you will have the same value of x. Okay? And then next, let's have the example number 2. Convert then solve for x. Logarithm of 243 base 3 equals x. So how are we going to do this one? First is we have the base 3 because we have logarithm of 243 base 3 equals x. So 3 raised to the power of x equals 243. That's how you convert logarithmic equation to exponential equation. And then, of course, we have our prime number. This will serve as our base to make the bases similar. So bring down 3 raised to the power of x, and the question is, how many 3's will you multiply to itself to get 243? So to manually do it, for those who have calculators, you can easily use your calculators. 3 times 3, it's 9, and then 9 times 3 is 27. 27 times 3 is 81. And then 81 times 3 is 243. And then let's count. 1, 2, 3, 4, 5. So you will multiply 3 to itself 5 times. And then you can now equate the exponents since the bases are similar. X equals 5. So that is already the value of x, which is 5. Can we use another base? No, because 3 is already a prime number. Unlike here, 4 is not yet a prime number. So we can have another factor of 4, which is 2. Okay, so that's why we use 2 as the base. All you need to remember to solve for logarithmic equation, you have to convert it first to exponential equation, and then after that, just perform some algebraic techniques to solve for the value of x. In the algebraic techniques, of course, it includes, you have to make the bases similar, and then after that, that's the time that you can equate the exponents to solve for the unknown variable. So I hope that's clear. Okay, so for my students, you can have a copy of this presentation. So, and here are the solutions in the presentation. Now, let's have convert then solve for x in the logarithmic equation. Logarithm of 2 base 4 equals 3x minus 8. Just remember that you have to treat this one as a single power. Okay, so our main base is 4, base 4, raised to the power of the terms in the right side, we have 3x minus 8 equals 2. Of course, the base that we can use here is the prime number, which is 2, base 2. So how many times will you multiply 2 to itself to get 4? 2 times 2 equals 4, therefore twice, times the original exponent, which is this, 3x minus 8 equals 2. So teacher, what's the exponent of 2? Of course, it's invisible 1. Alright? So since the bases are similar, you can now equate. So 2 times 3x minus 8 equals 1. Then distribute 2 to the binomial. We have 2 times 3x, which is 6x, and then 2 times negative 8, it's negative 16 equals 1. Then we need to isolate 6x, so we will have now 6x transpose negative 16 to the right. It's now 1 plus 16. And 1 plus 16 is 17 equals 6x. And we need to isolate x by dividing both sides by 6. So 6 divided by 6, 1, and of course 6 are cancelled. The 2 6's are cancelled. So we have now x equals 17 over 6. So which is now our final answer. X equals 17 over 6. Now let's have example number 4. Convert then solve for x. Logarithm of 125 base 5 equals x plus 4. So our main base is 5, of course. Raised to the power of x plus 4 equals 125. And then, of course, 5 is a prime number, so we can use the base of 5. Alright? So bring down 5 raised to the power of x plus 4. And then how many 5's will you multiply to get 125? Let's try. 5 times 5 equals 25. And then 25 times 5 equals 125. And then count 1, 2, 3. So 3 times. Then after that, you can equate the exponents to solve for x. It's now x plus 4 equals 3. And then isolate x, transpose 4, it will become negative 4. Then just bring down 3. So 3 minus 4 is just negative 1, and that's already the value of x. As simple as that. No? For you to be able to solve for logarithmic equation, just remember to convert to exponential. Then after that, make the bases similar, and that's the time that you can equate the exponents to solve for the unknown value. Right? Now, here are the solutions. Now let's have the problem solving. So let's have a problem which we can actually relate to logarithm. So pH is a measure of the amount of hydrogen ion activity, which is symbolizes by this, in a solution. And therefore, its alkalinity or acidity. pH is described as the negative of the logarithm of the molar hydrodium ion concentration and expressed as pH equals logarithm of hydrogen ion base negative 1. And then if the concentration of hydrogen ions is lime juice is 0.02 moles per liter, then the lime juice has a pH of what? So we are solving for the pH of lime juice. And then just remember for pH, when we are talking about pH, we are also talking about the alkalinity and acidity of a specific solution. Now, what are the given values? So the hydrogen ion of the lime juice is 0.02 mole per liter. And then for the pH formula, we have logarithm of hydrogen ion base negative 1. Alright, so the next thing that we're going to do now is we will just substitute the value of hydrogen ion in the given equation. So we have now logarithm of 0.02 base negative 1. Okay, so we have the negative here. So if you have your calculators, this is very easy to solve. Just click on the minus sign or negative sign. And then after that, okay, look for log. So some of the calculators, they have it as the second function. You just have to click shift first. And for other calculators, it's the main function. So log, look for log. And then open parenthesis 0.02. Right? And then click equal sign. And then after that, you will have this answer. And if you would like to round it off to the nearest tens to make it smaller, so we have 1.7. So the pH of the lime juice is approximately 1.7 and the unit of measurement is moles per liter. 1.7. Alright, so that's how you apply. So the logarithmic function as an application in chemistry and some other discipline. This is just additional information for everyone. Whenever you solve for problems, okay, word problems or real-life problems in mathematics, make sure to write the label or unit of the final answer because that's really important. Right? Next, let's have inverse function. So before we go to inverse function, by the way, for my students, it's from page 94 to 100 of your books, and then we have 105 to 113. Now, so when we are talking about inverse function, we have to talk about first one-to-one function because only one-to-one functions can have their inverse. So just like what you are seeing here, when a function has additional property that no two unique elements of the domain have the same value in the range, the function is said to be one-to-one. So just like, for example, the first one, we call it one-to-one because as you can see, the domain, the elements of the domain are uniquely paired to the elements of the range. So just like what you are seeing, there are no repeated elements in x and y. So therefore, this one is what we call one-to-one function. How about in the other one? In the other one, this is not one-to-one function because as you can see, the two elements of elements of the domain are paired to a single range. So this is not one-to-one because as you can see, it does not actually follow the rule of one-to-one function of having two unique elements of the domain. Alright, so no two unique elements of the domain have the same value in the range. So just like what you are seeing, there are two elements of the domain that have value 1 or same value in the range. So therefore, we can summarize that the second diagram is not actually one-to-one function, right? So not all functions are one-to-one. So you have to follow the rules. Okay. Now, a function f is one-to-one if and only if no horizontal line drawn through the graph of f intersects it more than once. So this one is horizontal line test. So for all functions, we are using vertical line test, right? But for one-to-one functions, other than the vertical line test, we are also using the horizontal line test. So when we say horizontal line test, it's the same rule with the vertical line test. So for horizontal line test, the horizontal line must not touch or intersect the graph more than once. So just like what you are seeing, let's have the first one. We have identity, absolute value, quadratic, and cubic functions. So for the first one, if we are going to draw a horizontal line like this, so as you can see, it only touches the graph once, right? So therefore, we can say that this one is an example of one-to-one function. How about the other one? If we are going to draw a horizontal line, so as you can see, the horizontal line touches the graph at exactly twice or more than once. So therefore, this is not one-to-one function or graph of one-to-one function. How about the other one? Yes, this is parabola and this is also a function, but it's not one-to-one because if you are going to draw a horizontal line, so it touches the graph twice or more than once, right? So it's not. And then the last one is function is a one-to-one function because if you are going to draw horizontal lines, okay, in it, as you can see, the horizontal lines will only touch the graph at exactly once. Right? So I hope that's clear. So given a graph, you can also identify if the given function is one-to-one or not. And then antonyms. So before we proceed with the inverse. So when we say genuine, what's the antonym of genuine? We have artificial. Then for evident, the antonym is hidden. For determined or sureness, okay, so if you are sure of what you are doing and what will you say, so you are determined of what you are doing or decision. Then the opposite is doubtful. So it means that we can relate this to inverse function because when we are talking about inverse functions, we are getting the opposite. Okay, so we are interchanging the elements of x and y or the domain and range. So just like what you are seeing here when we say inverse, an operation that reverses the effect of another operation. So just like this one, if we have the function r, which is equal to 1, 2, so this is xy, 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 xy. So if you are going to get the inverse of this function, all you need to do is to interchange the domain and range. So it's now yx, 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 yx. So how are you going to read it? Inverse of r. So it's being read as inverse of r. Inverse of r will be 2, 1, 4, 3, 6, 5, 8, 7. Okay, so that's the symbol for inverse. So if you will be seeing -1 as a power exponent, so it means that we are talking about inverse of the function. So you can only have the inverse of a function if it's one-to-one function. So just remember that you can have only the inverse of a function if and only if it's one-to-one function. Alright, so next. Given f of x equals 5x minus 20 and g of x equals 20 plus x over 5, verify if they are inverse of one another. Again, you have to verify if they are inverse of one another. So to verify if they are inverse of one another, let's go back to the operations and functions, specifically the composition of functions. So when we say composition of function, we are substituting the whole function to the first or to the other function. So just like what you are seeing here, we have f circle g of x. So it means if you're going to see this one, you are going to substitute g to f. And here we have g circle f of x. You are going to substitute the whole f to g. All right. So how can we say that? If these two functions are inverse of one another? Only if their composites are equal. So let's solve. For the first one, our main function is 5x minus 20. And the one that you are going to substitute to it is 20 plus x over 5, or the g of x. So you will substitute that. Then as you can see, you will just change x to this function. So as you can see, we have numerator of 5 and 5. So you can just simply cancel 5. What will remain will be 20 plus x minus 20. And then 20 minus 20 is simply 0. So what will remain is x. Okay? So it means that f circle g of x is equal to x. So that's how you will do it. And then the other one, we have the function 20 plus x over 5. So this one, and then the first function will be substituted. This. Then you will change x to 5x minus 20, which is the first function. And then after that, 20 minus 20 is also 0. What will remain is 5x over 5. Cancel 5, or 5 divided by 5 equals x. So therefore, we can say that g circle f of x is equal to x. So as you can see, they are equal. So we can say that they are inverse functions of one another. That's how you will verify if two functions or two or more two functions are inverse of one another. You just have to solve for their composites. Okay? And then they have to be equal. If they are not equal, they are not inverse of each other. Now, so let's have the process of solving for the inverse of function. So first we have replace f of x with y. Then the second one, we have interchange x and y. So it means that you will change the position of x and y. Then solve for y and then rewrite y with inverse of f of x, or inverse of the function x. So that's how you will do it step by step. Now, solve for the inverse of the function f of x equals 3x plus 2. So what are we going to do here is, first, let's follow the process. We will replace. So we will replace f of x to y. Okay? Y now is equal to 3x plus 2. And then interchange. You will interchange the position of x and y. So x now will be equal to 3y plus 2. So that's how you will do it. Interchange x and y and x, or vice versa. Then after that, you solve. What will you solve? The value of y. So you have to make sure that y is in the left. Okay, so therefore, we will transpose 3y in the left and then x to the right. So we will have negative 3y equals negative x plus 2. So you will transpose x, it will become negative x. And then after that, okay, you will just simplify, isolate y. To isolate y, you have to divide both sides by negative 3. Cancel this, you will have now y. And then if the denominator has a negative sign, change all to make this positive, or to make the denominator positive, change all the signs of the numerator, or the terms in the numerator. So we have now positive x, negative x will become positive x, and positive 2 will become negative 2 over 3. And then the last process is rewrite. So to rewrite, you change y to inverse of f of x equals x minus 2 over 3. So this is now the inverse of the function f of x equals 3x plus 2. So first is replace f of x to y. Then the other one, interchange the positions of y and x. And then after that, you will solve for the value of y. And then make sure that y variable is always in the left rather. And then solve until you get the value of y, and then rewrite, change y to the inverse of x. Inverse of the function x, or inverse of f of x, which is equal to x minus 2 over 3. Let's have one more. Solve for the inverse of f of x equals 4x minus 1. First is we have to rewrite, or rather replace. So f of x will become y equals 4x minus 1. And then we have to interchange. So interchange the positions of x and y. So we'll have now x equals 4y minus 1. And then we have to solve for y. So you have to make sure that y is in the left. And then transpose 4y, it will become negative 4y equals negative x. Transpose positive x, it's negative x minus 1. and then divide both sides by negative 4. So cancel this. Now you're able to isolate y. And then, so as you can see that the denominator has a sign of negative. So to make it positive, just change the signs of the terms in the numerator. So negative x will become positive x and negative 1 will become positive 1. And then last is you have to rewrite. So it's now inverse of f of x is equal to x plus 1 over 4. So this is now the inverse of the function f of x equals 4x minus 1. So replace, interchange, solve. Then after that, we have to rewrite. So that's the answer. Inverse of f of x is equal to x plus 1 over 4. Then let's have the last example before the problem. Then solve for the inverse of f of x equals x minus 2 over 2x plus 3. It's a rational expression. So first is we have to replace. So f of x will become y equals x minus 2 over 2x plus 3. And then we will interchange. So change all x's here to y. So it's now x equals y minus 2 over 2y plus 3. And then solve. You will solve for the value of y. Okay, so as you can see, since this looks like a proportion, we can use cross multiplication. As you, in the right, as you can see, it's a single fraction. So cross multiply. Okay, so it's now x times 2y plus 3. Then we have 1 here, just multiply it up. And then we have y minus 2. So whatever you multiply to 1 twice, then is always the number that you multiply. Identity property. Then distribute x. We will have now x times 2y is 2xy. And then x times 3 is positive 3x equals y minus 2. And then, just like the rule, you have to make sure that all the terms with y's will be in the left. So in this case, so xy will remain, and then 3x will be transposed, and then y will be transposed. It will become negative y, and then 3x will become negative 3x minus 2. So here, to solve for y, we have to factor out y. So we have a single y for the two terms here. So 2xy divided by y will be cancelled, but the remain is 2x, and then negative y divided by y, they are the same, so you will have an answer of negative 1 equals negative 3x. And then the next thing is, to isolate y, you have to divide both sides by 2x minus 1. We cannot anymore simplify this, therefore, the value of y, or the inverse, is negative 3x minus 2 over 2x minus 1. Alright, so and then after that, we will rewrite. So we will have now inverse of f of x equals negative 3x minus 2 over 2x minus 1. So this is the inverse of the function f of x equals x minus 2 over 2x plus 3. So we also followed process for the steps in solving for the inverse of a function. So it's the same as our final answer, which is inverse of f of x equals negative 3x minus 2 all over 2x minus 1. So I hope that you were able to follow the process or simple process in solving for the inverse of the function. Then let's have a problem solving. So for this problem solving, it's a temperature problem. Let T be the temperature in degrees Celsius. The temperature in degrees Fahrenheit is given by f of x equals 9 over 5x plus 32. Now we need to find C of x, or the inverse of the f of x. So C of x is the inverse of the given function, which converts degrees Fahrenheit to Celsius. Convert 14 degrees Fahrenheit to Celsius. So before we can convert 14 degrees Fahrenheit to Celsius, you have to get first the inverse of f of x, which is the C of x. Celsius to Fahrenheit is this formula. If you're converting Celsius to Fahrenheit, so use this formula, and Fahrenheit to Celsius, use the formula that we will be solving next. And then, of course, letter A, we have to find C of x, or the inverse of the given function, which converts degrees Fahrenheit to Celsius. So we have the main function, which is f of x equals 9 over 5x plus 32. This is for Fahrenheit. And then Celsius. Right? Okay. So change f of x to y first, and then you will have 9 over 5x plus 32. And then interchange. So interchange the positions of y and x. So that's why it's x equals 9 over 5y plus 32. And then after that, you will have to solve for y. Okay, so just like what we've learned, if there's a denominator, you have to remove that denominator. So multiply the whole terms to 5. Okay, so and you will have now 5 times x is 5x, and then it's not being displayed. So 5x equals, right? So 9 over 5y times 5, and then we have here plus 32 times 5. So if you're going to simplify 5 times x, it's still 5x, and then 9y, because you can just simply cancel 5, which is the goal, no? We are removing the denominator, 9y. And then after that, 32 times 5 is 160. Okay, and then you have to make sure that all terms with y's will be in the left and x will be on the right. So we will have now negative 9y, because if you're going to transpose 9y to the left, you will have negative 9y. And then after that, we have 160, and then you will transpose 5x, it will become negative 5x. Then after that, isolate y by dividing both sides by negative 9. So as you can see, the denominator is negative. Change the signs of the numerators. So you will have now 5x minus 160. We just interchange the place of negative 5x and 160. Then, rewrite, we will have now inverse of f of x equals 5x minus 160 over 9. Or this is now the formula for the Celsius. Now, convert 14 degrees Celsius to Fahrenheit. Okay, so first we have this, 5x minus 160 over 9. This is now our formula for Celsius. And then substitute or evaluate. We have C of 14 equals 5 times 14 minus 160 over 9. Okay, so that's our problem now. And then after that, so just to simplify, so 5 times 14, it will give you an answer of 70 minus 160 over 9. And then 70 minus 160 is negative 90 over 9. So your final answer, C of 14, is equal to negative 10 degrees Celsius. So this is the process. That's why we will have an answer of negative 10 degrees Celsius. So it's cold, right? So it's below the freezing point of 0 degree. So that's how you solve temperature problem involving inverse of functions. So I hope that you learned a lot from this lesson about logarithmic and about inverse functions. So if you have questions and clarifications, you can just go back to the specific examples that we discussed in this video. And then for my students, please don't forget to do this activity. I have a special instruction here. If when will you submit, and rather when is the deadline, and then like here for numbers 21 to 23, there's a special instruction that you have to equate to x first before you can solve for the value of x. And then after that, if you will get all this correct, you will get 18 points. So thank you so much for listening. I hope that you've learned a lot from our lesson for today about general mathematics for senior high school. Thank you so much. Please don't forget to subscribe on my channel, Teacher Dong. Have a great day, everyone.